All right, we're going to talk about the classic dichotomy in the theory of money neutrality. And this is the idea that changes in the money supply only change nominal items in the long run. They don't affect the real items. This is a theory, and I want to talk about this theory because it's a common one among economists. First, we need to talk about what's the difference between real items and nominal. Real items are things that are controlled for inflation. Or real items are the value of something in terms of something I care about. So for example, real wage is not my dollar I earn per hour, that's my nominal wage. Dollars per hour is nominal wage. My real wage is dollars per how much I can buy for that good of goods. It's how many goods can I buy with an hour of work. That's real version of something. So always think of real something as getting rid of the inflation idea and just how much of a specific thing can I buy with an hour of work. And what nominal things are things like dollars per something. And that'll be dollars per hour, dollar per something. That's nominal wages. Right? So nominal versus real. And real items are things like real wage, real GDP, the unemployment rate. All those things that we care about are real items. And nominal items we don't care as much about. Things like nominal GDP, nominal wages, the price level. Those are things that they change, we don't care. I don't care about what my actual wage is. I care about what my wages buy. I don't care what GDP, what nominal GDP is. I care about real GDP after correcting for inflation. So the idea here is that the changes in the money supply will only affect those nominal things, not the real things. So how can we walk through this? Here's the equation you need to know. It is M times V equal to P times Y. This is a key equation. I need you to know for this. It's not too bad though. M is the money supply. Okay. Just like we've learned in this class so far, money supply set by the Fed, controlled by the Fed, money supply. V is the velocity of money. This is the average number of times a dollar is spent. So it tracks, kind of, the average number of times a dollar bill is spent in a year. How many times has that one specific dollar bill been spent to buy things in a year? Now we don't actually track individual dollars, we just estimate the total number of times. It's done using this equation. P is price level. Price level is things like the GDP deflator or the CPI number. The only thing you got to be careful about with this is how this number is presented to you. This could be presented in the full format, like someone might say the GDP deflator equals 260. Remember when we found the GDP deflator, you used your nominal real GDP, then you multiplied by 100. You made it into an index. If I want to use this in the equation, I've got to pull that out like it's a percentage almost. So if I wanted to put this into an equation, I would need to put it in as 2.6. To kind of pull that 100 out, divide it by 100, just like you do something else. You could get it in this format. It might be presented to you as 2.6, and then you don't need to do anything to it. So just look at it and see how it's presented to you. Is it presented in the hundreds? If so, divide by 100 to get to the usable form of it. Or is it presented to you as the actual number itself? In this case, you can just use it how it is. That's really, really hard part of this. The Y is real GDP. Real GDP. So real GDP is GDP after you control for a price level. Which can bring us to something else. What would nominal GDP be? Nominal GDP would be the P times the Y. So this whole side over here is nominal GDP. So if you needed to find nominal GDP, and you knew M and you knew V, multiply them together, you get nominal GDP. Okay? So this is how we do it. Or if you wanted to find V, finding V is something I'm going to have you guys do in a minute. V would equal P times Y over M. Just rearrange it. So let's walk through this. Let's do a quick example of this. Let's see if we can find what makes sense. So here's an example. Let's assume that P is equal to 1.2. So I already adjusted it. I didn't give it to you as the full form. I might have given it to you as P equals 120. And then when you put it into the equation, you need to put it in as 1.2. So just correct the price as needed. I don't need to correct it here. Let's say Y is equal to $12 trillion. That'd be a relatively decent sized real GDP. And let's say the current money supply is 10. And I want you to find the velocity. That's not too bad. We can do this. Just plug it into the equation I just gave you. The velocity of money would equal, and you can either use this equation or you can plug it in here and then solve for it. Let's do that. Let's plug it in there. That'd be 10 times V equal to 1.2 times 12. So I just use this equation. And then I would just do my math and get the answer. So this would be what? 14.4. This is 10V equal to 14.4. So V would equal 1.44. Hopefully I did my math right there. On the board, it always looks wrong. So this says in a year, on average, every dollar bill is spent 1.44 times. It's spent more than one time. So that's velocity. And that's how you find velocity. Finding velocity is not too bad. Once you have this other data, we can find velocity. All right? So what is this? How can we use this to show this theory of money neutrality? And the theory says if M goes up, real things don't change, only nominal things change. So this is what the theory says. If M goes up, then of these variables, V doesn't change. That's not a real variable. And Y doesn't change. Right. So the real variables don't change. The thing that does change is only P changes. That's what the theory assumes. Right? So the theory says if we increase the money supply, we're only going to affect the price level. We're not going to affect the things we care about, specifically in this case, Y. And let's show how that would work. So here's an example of how that would work. So if we assume this is true, then if M increased to $12 trillion, what's that going to do to this setup? So how do we do this? Well, our new M, so we use this equation again. Our new M would be 12. Our V, as we know, is going to stay the same. We're assuming it stays the same. We found that is 1.44. Our P, we think, is going to change, so we're going to leave that as a variable. And our Y, we think, is going to stay the same. So notice what I did there. I kept the things that I thought were going to stay the same. The V and the Y, I kept those as the values I found before. And I put in the new M. I'm going to find this P. And what's this P going to be? The P is going to be equal to 12 times 1.44 over 12. Oh, I didn't mean to make that clean of a question. In this case, those 12s are going to cancel out. We're going to end up with 1.44 again. That's just a kind of a lucky situation. You're not always going to be able to cancel this out. You'll just get a number from this. In this case, we're going to get 1.44 from this also. This will be the new price. The price went from 1.2 to 1.44. What does that mean for us? Well, what that means is, if we did the math on this, we could, it's not too hard. And when the price goes from 10 to 12, that's a 20% increase. What's that going to do to the price level? It goes from 1.2 to 1.44, which is also a 20% increase. So that theory of money neutrality says is, if I increase the money supply by 20%, all I'm going to get out of it in the long run is 20% inflation. And I think that makes some sense, some logical sense to it. The idea of how you work through all this stuff is using this equation. It's just a key equation we're going to use. And the idea is that. The idea is we assume that V and Y don't change when the money supply changes, only P does. And how much it changes by is the exact same percent that the money supply changed by. And a lot of people believe in this theory that the idea is if we increase the money supply, all we're going to get out of it is inflation by the exact same amount in the long run. And therefore, the Fed doesn't really control long-term real measures that we care about.